6. Determine the coordinates of P. And so here is P here. And let's go ahead and put SS, so 16 and 5. So that we worked out already. All right, so cool. So now we need our coordinates of P. And to be able to do that, firstly, let's first have a look at our equation of PQ. All right, so we have the gradient, we have the a point, so we can get the equation of line PQ. So let's start off there. That's the information we know the most about that line. So equation of PQ, and we can use y minus y1, and in this instance this would be y plus 3 minus minus, so that minus minus becomes a positive there, and x minus minus 2, so x plus 2. And that's how we end up with y is equals to x minus 1. So that gives us that equation, because how this helps is that point P is on that line PQ. So what this does is, if that entire equation of that line is y is equals to x minus 1, that means that whatever value, or whatever the value for y is, or in this instance whatever value of x, we subtract 1, and that's how we get our y value. So if we were to use the coordinates of P, which is a and b, what we can automatically say is that a is equals to b plus 1, because in this instance here, whatever the x value is, if you're going to subtract 1 to get the y value, we just need to add 1 to the y to get the x. So this is, we can just call this maybe equation 1. We maybe use this down the line, because remember this is a 6-mark question, so there's possibly going to be some simultaneous equations here. So this is the first step. This brings us a bit closer. And what we can then do from there is we can go ahead and use we were given the distance of QP, so we can use the other equation and get A and B from our distance formula. So yeah, let's use PQ. This is the one way to do it, using the distance formula. So here PQ squared, and this helps us how, because we know the distance is 7√2, and here we can put our coordinates, which will be x2. We can say a minus minus 2, so a plus 2 squared, and b minus minus 3, which is b plus 3 squared. And thereafter we can square both sides, since we have some whatever third equation here that cancels out with that. And on the left hand side, we left with 7 squared times 2, so 49 times 2, which is 98. And on the side, the square root goes away, so we left with a plus 2 squared plus b plus 3 squared. Okay, now this is good. Now what we can do now is, since we have this equation, we already have an equation for a. So a is equals to b plus 1, so we can replace a in this equation with b plus 1. And here we can say 98 is equals to b plus 1. Just change this. B plus 1 plus 2 squared plus b plus 3 squared. And thereafter we are able, and as you can see in this equation, the only thing that's unknown now is b. So now we can open up everything, we can FOIL everything out, open all our brackets. So it will be 98 is equals to b squared plus 6b plus 9 plus b squared plus 6b plus 9. And if we sort out all our like terms, put everything on one side, what we do get is 2b squared plus 12b minus 80. So now we can solve for this, we can factorize this, and we can divide everything by 2 to make it easier here. So divide each term by 2, we get 0 is equals to b squared 6b minus 40. And factorizing this last step here, and since the last term is negative, we'll have one positive, one negative. We get b plus 10 and b minus 4. And we get our two b values. But remember, at the very beginning in this question, they said that a and b can only be greater than 0. So we'll only accept the one answer. So here we get b is equals to minus 10 or b is equals to 4. So that would be not applicable. We can reject that, and we can accept the fact that b is equals to 4. So once we have our b value, we can then go ahead and sub this b value into our a value into the equation that we worked out, and we can bring that down and get our corresponding a value, which is the coordinate of p, which is what we wanted. So therefore a is equals to 4 plus 1, and in this instance a is therefore equals to 5. And we therefore have our a and b value, which is the coordinates of p, which is 5 and 4. Okay, cool. So this is the one way to do this, and the reason we went about using the distance way is because they gave us the distance of QP. We didn't have a and b, and we were able to get the equation. So that is one technique. The other technique you could have gone and done is you could have constructed maybe a 90-degree triangle and constructed a triangle between P, Q, and potentially M here or somewhere here, some sort. And thereafter, you could have used trig to actually get your corresponding A and B values. But I would say this is the way with the least complications. Maybe a bit longer, but yeah. So we get our P, which is 5 and